The solar system. A swirling symphony of matter and space, filled with more wonder and mystery than we may ever reveal in the lifetime of our species. From the fiery cauldrons of Mercury and Venus to the frozen abyss of Neptune and beyond, our solar system is still very much a vast, uncharted ocean of inhospitable emptiness, speckled with pearls of matter we call planets and moons. As we enter the 7th decade of spatial discovery, mankind has begun to pull back the curtain on our most beautiful and terrifying icons, the gas giants. These gargantuan bodies of dense gas are still wholly unknown, but today science is bringing us closer than we ever have been before. With so much to explore on these titans of the night sky, any information we can glean from further encounters provides a wealth of new possibilities in science, technology, and mathematics. However, there is one giant in particular that stands out from the rest. As little as we know about this body, it still captures and keeps the wonder of every child that reads about it, or a mature astronomer that spots it hovering above.
That's one of the things that's exciting when you're doing outer planetary exploration, is that you don't always understand what you're looking at right away, and yet you're inclined to keep going back and saying, well, you know, I haven't thought about it this way. Can I understand it in some other way?
Today, we explore the greatest of the Galilean planets, an iconic and mesmerizing ball of unadulterated intrigue. Born from the leftover materials during the creation of our Sun, Jupiter is a swirling sphere of gas and liquid. Its outermost layers are hydrogen and helium, and in fact, had it acquired more of those elements, it too could have been a sun. Unfortunately, its mass is not great enough to create the immense pressures and heat, and thus will never ignite in our lifetime. However, the pressure is still immense, so much so that hydrogen is compressed into a liquid form below the planet's atmospheres. Moving further towards its core, the pressure becomes so great electrons are squeezed off of the hydrogen atoms, allowing the liquid hydrogen to conduct electrical current, similar to liquid metal. Scientists believe the core of Jupiter to be a massive ball of magnetized liquid hydrogen. This would explain Jupiter's magnetism. Much like Earth, Jupiter has magnetic fields, only if Earth's are like a refrigerator magnet, Jupiter's would be superpower electromagnets. Although we can scan Jupiter from afar, we have not been able to truly inspect the inside of Jupiter, as the pressure and heat would crush, melt and vaporize any man-made craft. Jupiter has been on our minds since the infancy of human civilization. Ancient Romans named Jupiter after the king of the Roman gods because it was the largest of the 5 planets they could observe through the unaided eye. Jupiter's day-to-day life is turbulent, to say the least.
Everything about it is extreme. It's a planet on steroids, right? It is the most extreme in every way it can be. So it has the strongest magnetic field, the strongest gravity field. It has the most harsh radiation. It's spinning super fast. I mean, everything about it is this extreme environment.
It rotates on its axis once every 10 hours. This is the fastest day in our solar system. These intense rotational speeds are credited to the planet's lack of solid surface. Along with this rotational speed comes high-velocity winds. Where typically on Earth winds exceeding 70 miles per hour are reserved for our version of stormy weather, on Jupiter, winds exceeding 300 miles per hour are a normal occurrence.
Jupiter is the biggest, baddest planet there is. It is the monster of the solar system.
In our universe, there is no other sentinel on watch that protects us like Jupiter. This gargantuan big brother is estimated to absorb 6 to 7 planet-impaling objects per year. In addition, it absorbs or deflects tens of thousands of pieces of space debris. This makes Jupiter a handy neighbor indeed. Constant winds are what many speculate allows for the painted like trademark swirls and streaks of crimsons, browns and whites. The recent passes of the Juno craft have captured details of these clouds in breathtaking images. These coloured striations are likely just plumes of poisonous sulfur and phosphorus containing gases rising from the superheated core. Beautiful as they may appear, these mesmerizing patterns of swirling gases represent the violent, inhospitable nature of the planet. One such marking, though, has been observed and studied for well over 300 years. It's the object most synonymous with the name Jupiter, and its uninspired title is merely a cover for its awe-inspiring characteristics. Jupiter's most widely known feature is not really a feature at all. This bright red oval is actually an ancient storm that has likely been stirring its atmosphere for well over 300 years. With no surface features to interrupt its path or velocity, this storm will continue to glide along its path for quite some time. Recently, scientists have observed a slight shrinking of this storm. Though the Great Red Spot is roughly 1.3 times as wide as Earth, recent passes of satellites have confirmed the storm is actually growing in height while it dwindles in width. In fact, scientists predict that this famous swirling storm may finally cease to exist in the next 20 years. Most of Jupiter's atmosphere moves in a counterclockwise rotation around the planet, but upon close observation of the red spot by Voyager, scientists notice that the storm is moving slightly clockwise against the flow of the other atmospheric bands. The clouds in this storm are also much higher and have a cooler thermal signature than the other gas clouds covering the planet. Recently, an anomaly was discovered far above the clouds of the Great Red Spot. Nearly 500 miles above the storm, thermal imaging determined a pocket of vastly hotter atmosphere than the rest of the planet. The explanation is that the storm is projecting both acoustic waves and gravitational waves, and where they collide, a tremendous amount of energy is released in the form of heat. The Great Red Spot is still a hotly debated enigma, and likely will be until we can send probes close enough to take more accurate readings. Jupiter's powerful electromagnetic fields currently prevent us from achieving this, as the planet spews out massive amounts of radiation that damage today's current array of highly sensitive equipment. With time, we may finally be able to understand more about this storm that has captivated our attention since the red giant was first discovered. While analysing the planet itself is still a challenge for modern astronomy, Jupiter offers scientists several lower-hanging fruit that are ripe with possibility to unlock several of life's greatest mysteries. With more than 65 known celestial bodies orbiting Jupiter, no other planet has as many moons to explore. Galileo discovered the 4 largest moons, Io, Europa, Ganymede and Callisto. These moons are of particular interest to scientists for a variety of reasons. Io, Europa and Ganymede orbit Jupiter in what is known as a Laplace resonance. This pattern causes extreme gravitational strains on all the moons as they constantly align and pull on each other in relation to the gravitational pull of Jupiter. It is the constant pulling, stretching and contortion that give these moons some of their most interesting characteristics. Io is the closest moon to Jupiter, and its orbit is also the fastest, circling Jupiter in just under 1.8 days. The constant pulling between its sister moons and Jupiter causes intense friction within the planet, and thus it is the most geologically active body in the solar system, with well over 400 constantly active volcanoes. Its yellowed surface is the result of sulfur and sulfur dioxide frost. Io is also covered in mountains that are formed as the surface is stretched and relaxed. Some of these mountains are taller than Mount Everest, but unlike Earth, Io is comprised of mostly silicate rock surrounding a molten iron core. Io's constant geological activity makes it seem unlikely of being capable of supporting life. However, as life has been discovered in the scalding hot acidic pools surrounding Earth's volcanoes, or the thermal vents miles below the ocean surface, it is not impossible to imagine highly adapted organisms thriving in an otherwise uninhabitable environment. Europa is the smallest of the Galilean moons, but holds the most intrigue for scientists.
Europa is rising in terms of our interest in the scientific community because the possibilities are enormous in terms of what it could support for life.
This ice-covered moon's unique characteristics have driven NASA to observe the object with more scrutiny in recent years. Although Europa has been bombarded by meteorites for billions of years, it's regarded as the smoothest body in our solar system. While our moon and nearby planetary neighbors are covered in mountains, craters, valleys and trenches, Europa's unbelievably even surface seems unlikely. It is this characteristic that has led scientists to speculate that its ice surface is constantly renewing itself with a vast ocean just below.
We have to go back. There is too much evidence right now lying around on the surface, the red stuff, that suggests that something's going on there. And by golly, we really have got to go back and get an understanding of this is another solar system object that's active. We've got to go back there.
The persistent resurfacing and freezing is believed to be caused by the same tidal flexing that causes Io to perpetually erupt. It is theorized the immense pressure and thermodynamics caused by gravitational pulling keeps Europa's ocean in a liquid state and thus possibly life harboring.
Europa is a bizarre place, very unusual surface, very young surface, and that there is probably a salty ocean in Europa today. Now we know that on Earth, everywhere that there's water, we find life. So could Europa have the ingredients to support life?
While the Juno mission focuses on Jupiter, scientists believe this moon may be the key to unlocking the mystery of finding extraterrestrial life. In 2017, NASA formally announced the Europa Clipper mission, designed specifically to pass the frozen moon 45 times, investigating its capacity for sustaining life. As it passes around, the probe will fly through plumes of mist sprayed from fissures on the surface. These giant plumes, only just discovered, could very well hold the first signs of life outside of Earth. If it is determined that Europa is habitable, more missions could be created to further explore the icy orb and possibly unlock one of humankind's greatest mysteries. Ganymede and Callisto are the third and fourth Galilean moons and are believed to both have similar salt oceans several hundred kilometers below their exterior. However, the Galilean spacecraft noticed something unique about Ganymede that was entirely unexpected. Ganymede has a magnetosphere, a magnetic shield formed in celestial bodies with active metallic cores. This magnetic barrier protects the planet's surface from solar wind and, like on Earth, protects life from toxic levels of radiation. With the presence of a magnetosphere, Ganymede's salt ocean could potentially contain life. Although Ganymede's surface appears to be somewhat scathed from interstellar acne, Callisto bears the true abuse of space debris. It is possible that Callisto appears more cratered due to the lack of orbital resonance the other three Galilean moons share. However, its larger orbit is exposed less to Jupiter's radiation, making it the ideal moon for scientists to create a base of operations to continue exploration of the Jupiter system. Although Ganymede is the only known moon to have its own magnetosphere, all of the Galilean moons orbit within the massive protective shield Jupiter emits. Although the Galilean moons are Jupiter's 4 largest, it wasn't until the early 1900s that many of Jupiter's other moons were discovered. Of all the planets in our solar system, Jupiter has the most moons. Beside the 4 Galilean satellites discussed so far, the red giant has an additional 65 known moons, and possibly more still yet to be discovered. Jupiter's moons are divided into 2 distinct groups, regular and irregular satellites. Regular satellites have stable, prograde, nearly circular orbits and are further divided into 2 subgroups, the inner satellites and the outer satellites, also referred to as the Galilean moons. We now know that in fact the 4 inner moons are responsible for Jupiter's faint set of rings. These stripes of space dust and small rock were formed after surface impacts ejected debris far beyond the gravity of these rapidly moving satellites. It was nearly 300 years between Galileo's 1610 discovery of the largest 4 and E. Bernard's discovery of Amalthea, and inner moon and Jupiter's 3rd closest satellite in 1892. So what took so long for so many moons to be discovered? For starters, these moons are magnitudes smaller than the Galilean moons. Another reason is that 4 of these smaller moons orbit Jupiter closer to the red planet than the closest Galilean moon, making them much harder to spot amidst the varying atmosphere of Jupiter. Together, the 4 inner and 4 Galilean moons make up all of Jupiter's regular moons. The rest of the Jovian planet's moons are grouped into the irregular category. These small moons with varying shapes and features have highly eccentric and in many cases retrograde orbits. Many of these tiny companions are mere miles across in diameter, while the Galilean moons are planet-sized. And don't think keeping track of these mere space pebbles is easy. As of today, several of Jupiter's moons are lost. With orbits so eccentric, scientists still have not been able to map their paths, and so occasionally they become misplaced. Though we are certain to see them again on their next pass by Jupiter, no one knows exactly when that will happen, or if we'll be able to learn enough at that time to track them indefinitely. One reason for these highly elliptical orbits is that these moons were actually caught by Jupiter's gravitational pull. Today, it is believed many of Jupiter's smaller satellites were actually asteroids and other galactic formations ensnarled by the red planet on their icy cruise throughout the solar system. By the time we finish tracking all of them, we may find a few even more undiscovered moons to worry about losing. And yet, with all that we know about Jupiter's and its vast array of orbiting partners, there is still so much that we are discovering, even today. In January 1979, the Voyager 1 spacecraft took the first close photos of the gas giant. These photographs answered many of our questions, but also raised new ones. What was beneath its swirling clouds? What was its core comprised of, and how big was it? To answer these questions, NASA and JPL Laboratories needed to get closer than ever before with the most sophisticated Jupiter mission ever conceived. Since 2016, the Juno spacecraft has been orbiting Jupiter, collecting all the information to answer the questions arising from the Galileo missions. While Galileo told us what questions to ask, Juno will give us the answers we've most been waiting for.
Ignition and liftoff of the Atlas V with Juno on a trek to Jupiter, a planetary piece of the puzzle on the beginning of our solar system.
NASA's Juno space probe, like Jupiter itself, is also named according to ancient mythology.
We named it Juno because that's the sister and wife of Jupiter in Roman mythology. So, you know, in mythology they did things a little bit strange. They were both the sister and the wife, but basically she was the queen of the gods and Jupiter was the king of the gods. And there was a story about how Jupiter was sort of up to no good and being mischievous and saw his wife coming, Juno, and said, "Oh no, I better hide my mischief," and he cast a veil of clouds around himself to hide. And she had her own special powers and saw a hint of what was going on and then used her powers to see right through those clouds and see what Jupiter was really up to. And that's exactly what our spacecraft Juno does, is it uses secret powers, which are science instruments from a unique perspective, and we see through the clouds of Jupiter to see the true nature of Jupiter.
After the successful Galileo missions from 1989 to 2003, NASA created and launched the Juno probe. Only the second mission dedicated to studying Jupiter, Juno has picked up where Galileo left off. The mission of studying Jupiter's atmospheric, magnetic and gravitational features will help define its nature and give us a better understanding of our Jovian neighbour. The probe is a large titanium box outfitted with sensors and filled with various computers, processors and data recorders.
Jupiter is, if you wanted to pick, aside from the sun, the scariest environment we know of to send a spacecraft to, Jupiter would be the place to go, because Jupiter has this gigantic magnetic field which traps a lot of charged particles that get accelerated along the magnetic field lines. It builds up this huge radiation field. If we were to leave our spacecraft bathing in that radiation, it's just not designed to deal with that.
Titanium acts as a shield from the immense radiation Jupiter is surrounded by, and thus protects the vulnerable devices packed within. Without the titanium shield, Juno would merely be a multi-million-dollar paperweight hurtling through space at 80,000 miles per hour. Launched in 2011, it took nearly 5 years for this spacecraft to reach Jupiter. Only after an orbit around the Sun and hitching a ride from Earth did the spacecraft have the correct speed and timing to sling itself through the inner solar system and bridge the immense gap between our inner planets and Jupiter. The magnetosphere is the planet's first line of defense against solar winds. Jupiter's magnetosphere is the largest object in our solar system, spanning well beyond the orbit of Saturn. Juno is also able to capture auditory frequencies emitted from Jupiter as it orbits the planet. Though these frequencies are well beyond the limits of human listening, NASA has adjusted these clips to let us hear the unbelievable sounds of our gargantuan celestial neighbour. Juno's WAVES instrument on board the craft recorded audio of solar wind bouncing off of Jupiter's magnetosphere upon its approach to the planet. You can hear the background noise increase as the density of plasma increases. The tones heard periodically are still being studied by NASA as to their exact cause. As Juno finally approached and passes the edge of the magnetosphere, the equivalent of a sonic boom occurs, called a bow shock. These audio files sound more like an eerie backdrop of some scary movie. Although you cannot hear this sound in space, these radio waves provide us with an auditory fingerprint of Jupiter's intense magnetic field. Juno is now on its 18th orbit, or perijove, orbiting the planet Jupiter, halfway through its mission that is projected to conclude in 2021, each time gathering a wealth of knowledge and understanding. The craft had several key pieces of technology aboard designed to specifically seek the answers we have yearned for, while evading the constant bombardment of magnetism, radiation, and gravitational anomalies that would otherwise have led us askew in our search for truth. Juno has passed closer to Jupiter than any other craft in history, and has given Earth the best view of Jupiter ever witnessed.
So the next pass close to Jupiter is July 11th, and we're going to go right over the Great Red Spot. And that's really going to be the first time that we get a close look at that and to see what it's like underneath the top surface layer. I mean, how deep are the roots to that? That's a 300-year-old storm. A lot of scientists believe that the roots must be very deep. When we go over with our microwave radiometer, we're going to see, is it the same as the zones and belts, or is it very different? And nobody really knows.
From the various bands of clouds swirling around with varying speeds and directions, to the awe-inspiring red spot. Because of the high levels of radiation ejecting from Jupiter, careful planning was taken to assure the survival of the spacecraft over its mission lifespan.
The Juno mission is unique because it's the first time that we've ever gone in a polar orbit, which goes from pole to pole, over the North Pole, through periapsis, and under the South Pole. All the other missions we've done and all the observations we made from Earth were made from the equator. And you don't see the poles very well if you're sitting on the equator.
On a highly elliptical 53-day orbit, the Juno probe dives into Jupiter's radiation belt with unflinching resolve. Each pass will subject the probe to higher concentrations of damaging particles. The benefit to this unorthodox approach to orbit is our clear view of the poles. With each pass, Juno will be collecting data, then flying out into space to avoid further radiation and to download all of the scientific revelations to NASA. Once the data has downloaded, NASA will begin uploading its new set of instructions. This set of instructions will be the new attack plan for Juno. While the JIRAM, or Juno Infrared Auroral Mapper, was designed to closely inspect Jupiter's powerful aurora, it also has to be able to closely observe the planet's cloud cover over the poles. This data can be used to construct 3D renderings of Jupiter's infrared emissions, giving us a more intimate portrait of the gas giant's newly discovered patterns of polar storms.
This instrument makes thermal maps of Jupiter. So the images are showing you what's warm, hot, cold on Jupiter. And one of the things you can see right away is the center of some of these hurricane-like storms are cooler than the surrounding area. And sometimes you go over a warm spot. And we went over one that was very small that seems hotter than the surrounding area. And that's very similar to what Galileo probe went into back in 1995.
By orbiting over the poles to Jupiter, much of the ejected radiation could be avoided as Jupiter's magnetosphere acted as a shield. The photos captured are nothing short of breathtaking. While the pictures that we have received from the Juno mission thus far have been revealing Jupiter in higher detail, no picture thus far has illustrated its tumultuous atmosphere like this image. Taken on the night side of Jupiter's North Pole, this picture shows Jupiter's super lightning storms in unprecedented clarity. While the exact origin and nature of these discharges remain a mystery, no clearer evidence has ever shown the immense and cataclysmic lightning storms that we have been yearning to view since Voyager 1 hinted at their existence over 40 years ago. Much like the northern lights here on Earth, passing solar wind and radiation can be seen as glowing tails from Jupiter's poles. These first glimpses of Jupiter's splendor don't even begin to scratch the surface of discovery buried deep beneath the clouds. These 60-kilometer thick plumes of hydrogen and helium were no match for the technology on board Juno. Depth, thermal signatures, and even radio waves were all recorded by Juno and sent back to Earth for analysis. The Juno spacecraft will be reviewed and a determination will be made to its future endeavors. If enough of the spacecraft is working as expected, and there are still valuable facts to be uncovered, more flybys by this specialized spacecraft will be budgeted. If, however, the spacecraft is unable to dutifully carry out further missions, it will gently be pushed to slowly fall into Jupiter's gravitational pull and eventually be vaporized on its long, violent journey towards the core. Why trash such an expensive and useful probe? NASA was concerned that had Juno landed on one of the more interesting Gallian moons, there was too great a risk of contaminating the environment with Earth-born organic life, thus possibly irrevocably altering that moon's existence and further masking us from the truth of whether or not life exists elsewhere. By sending the craft into Jupiter's core, no trace of the ship or its possible organic life would ever risk tarnishing another astral body. time will tell if NASA approves a mission extension to further explore the mysteries of Jupiter. With terabytes of data still streaming in, scientists will be analyzing all the secrets hidden beneath Jupiter's hazy exterior. In the coming years, more missions are planned for the Jovian system. The Europa-Clipper mission will push man's exploration of life to the very edge of our reach. With all that the Jupiter system has to offer, one thing is clear: the Jovian planet is by far the most fascinating object in our solar system.